All right, everybody, thanks for joining us today. So, welcome to another session of Explore by the Seat of Your Pants. And for those of you who don't know, our goal at Exploring by the Seat of Your Pants is to bring science, adventure, exploration to classrooms across North America and soon to be beyond. Welcome to another session of Explore by the Seat of Your Pants. And for those of you who don't know, our goal... I had the live session going as well. So I'm Sarah Privado, and I'll be your host for today. So thank you for joining us. And as February comes to a close, we had a great month filled with women in science and exploration, which brings us to our speaker. And today we are very lucky to have Sarah Seabrook joining us. Sarah is an avid ocean explorer, and she looks for life in areas of the ocean that have never been seen by humans before. So Sarah is interested in looking at habitats that are fueled by chemicals instead of the sun, and how this could relate to the possibility of life on other planets. Sarah is currently pursuing her PhD in ocean, earth, and atmospheric science at Oregon State University, and studies chemically fueled ecosystems known as ocean seeps. And through studying these habitats, they have brought Sarah to embark on expeditions in the Pacific and Arctic Oceans. She's dove under meters of sea ice in Antarctica and explored deep sea with remotely operated vehicles. And in addition to venturing to these incredible places, Sarah also works to connect with the public and to inspire the next generation of scientists to get passionate about the ocean. So pretty cool work there. So before Sarah gets started, I'm just going to go around and introduce the classrooms we have joining us live. And what we'll do is we'll go around, I'll unmute your mic so you guys can say hello. And then after Sarah gives her talk, we'll go around each class for a question. And if we have some time, we can do some extra ones. So as a reminder for those who might be joining via the YouTube live feed, there is a YouTube chat sidebar. So classrooms that may be joining us there, send in your grade and location, and we'll try to get some of your questions in as well. So let's go ahead and meet our classrooms. I'll start with Miss Zimmer's classroom. They are a 6th grade class from Milton. If you guys want to go ahead and say hello to everybody joining us today. Hi. Hey guys. And then we also have Mr. Adams' classroom from West Jefferson. They're a grade 5 class. If you guys want to say hello, you have the floor. Hello. Hello. We also have Miss Ragsdale classroom coming in from Grand Junction, US, and they are a grade 8 classroom if you guys want to say hey. Hey guys. And then we have Claire coming in from Marine Academy of Science Technology in Highlands, US, but her camera is not on. But hey, Claire. So Sarah, if you want to get started, are you screen sharing at all?
I will be screen sharing, yeah.
Okay, awesome. So you just know to click the green screen share button for the whole screen to be shared. Okay, awesome. All right, and without further ado, we have Sarah Seabrook.
Thank you. I'm really excited to be here talking with you guys about what I study. I love what I study so much, and I'm really excited to be able to share it. As Sarah said, I am an oceanographer, and oceanography is a really broad field. You can study how currents move in the ocean. You can study chemistry in the ocean. You can study geology in the ocean. And what I focus on is biology in the ocean. I focus on how animals interact with different habitats within the ocean and how those interactions can be related to ways of life existing that we never thought possible, even on other planets. And so I have some slides for you guys today, and I have some videos from the deep sea that we've collected with remotely operated vehicles on expeditions that I've been on. And I also have some videos from under the ice in Antarctica to share with you. So I'm going to start the screen sharing now. Okay. And I'm going to start my PowerPoint. So the oceans are a really big area of our world, and they cover 70% of the Earth, and they're really, really deep too. The deepest point in the ocean is 10,994 meters, or 35,000 feet. That's the Marianas Trench, which is near Japan, and that equals about 28 Empire State Buildings. And as we've spent time looking out at the ocean over hundreds of years, a lot of people have really wondered what's out there. And I know when I was a kid, and I grew up in Florida, and I would stare out across the beach and just wonder underneath the waves what all existed. And starting in the late 1800s, there started to be a lot of focus on trying to explore in the ocean and figure out what's living down there. And this is the Challenger expedition, which was the first expedition that really started the whole field of oceanography. And that was in 1872, which is only a little over 100 years ago. And that really shows you just how new of a field oceanography really is and how much more there really is to discover within it. And as we discovered, we knew for a while that there were a lot of fish and other animals that could live in the shallow part of the ocean. But we had really little idea what could live in the deep sea. And that's what really fascinates me is this unknown world in the deep sea that we're really only just starting to understand in the past couple of decades. And so we focused on these shallow waters for a little while, and then we moved on to try and see, okay, what else is out there? We knew that life would be limited by food in the deep sea, just like we are limited by food. Our health is driven by how much we can eat, and for animals, it's the same thing. And so in the ocean, animals have to be able to have food to be able to live. And that's what we have always thought really limited life in the ocean. We know that on land, plants can get energy from the sun, and this is through a process called photosynthesis. And this is the basis for everything we eat. Salads that we eat, burgers that we eat, everything comes down to consuming this energy derived from the sun. And same in the ocean, we found out about these little plants called phytoplankton, and they live in the surface of the ocean doing photosynthesis just like the plants on land to be able to make energy. And this energy is distributed across the ocean to act as food for all animals living in the ocean. And we knew that these plankton could break down and sink into the ocean. But we thought for a really long time that because the ocean is so deep, 28 Empire State Buildings deep, that by the time that all of this broken down plankton would make it to the bottom of the ocean, there wouldn't be much left. There wouldn't be enough food to support a large amount of animals. So then what is in the deep sea? Well, for a long time, this is what we thought was in the deep sea. We thought it was just black, dark water, and there was not much life in it. In fact, there was a theory that the limit of life was at 1,800 feet or 540 meters. That's really, really shallow. And as we started to take ships out and use dredges and use nets to pull up whatever was in the deep sea, if anything, we started realizing that there actually was a lot of animals that were coming up in these dredges and in these nets. And so then we were wondering, well, is life surviving down there? And as we kept looking around, we started to see all of these indications of life thriving in the deep sea. And we saw that they lived in really weird ways. And you can see here in this picture, these animals are letting off light. And that's because in the deep ocean, there is no light. After 600 feet, or about 200 meters, there is no more light that makes it down into the ocean. So these animals have developed these really unique strategies of finding food, of communicating, of making friends with each other. And a lot of that is from bioluminescence, as you can see here. And we found this as we've explored further into the ocean and explored deeper down and been able to spend longer down there. And we do this through using remotely operated vehicles, human submersibles where humans go down themselves thousands of meters deep into the ocean. And as we've done that, we've started to see that not only are there these really weird types of ways that life can live, but there's also life that looks just kind of like what we see in shallower areas. And so this video here is from some deep sea explorations that I took part in with the EV Nautilus. And all of these are taken from off the coast of West North America, so off of Canada, off of Washington, Oregon, and California. And all of these videos are from thousands of meters below the ocean. This one here is 1,300 meters below the sea surface. But you can see it in an octopus, just like we're familiar with seeing in the shallower waters. You can see crabs. These white vase-like things, these are sponges that are filtering out all of that plankton that's sinking down from the top of the ocean that I was talking about. And these crabs are just feeding in the water, bringing in food. You can see these fields of sea stars, all those little tiny white legs you can see poking out of the mud. All of those are sea stars that are just covering the surface, and they're consuming all of this broken down matter that has come from the top of the ocean. You can see more sponges. You can see fish. And this is a really, really cool part of the deep sea, is just how much really resembles what we're used to seeing everywhere else. And there's this crab, and then this hagfish, which is a crazy cool animal that can tie itself into knots, as you can see here. And so how does life survive in the deep and dark ocean? Well, as I've been mentioning, there is this rain of broken down phytoplankton and other animal parts that goes down to the bottom of the ocean that can act as food. But is there any way else? That's what we used to wonder. We would ask, okay, it's crazy though that we can see like this much life. You know, is this really the only way that life is surviving down there in the deep, dark ocean? As we started to be able to explore further, we discovered what's known as hydrothermal vents and methane seeps. And this is really the focus of my research, are these habitats that make food with no sun. And this happens from chemicals that are deep within the seafloor being released through the seafloor into the ocean. And this provides food for animals through a process called chemosynthesis, which is similar to photosynthesis, but instead of using the sun, these animals are using chemicals. And the first discovery of a habitat like this was in 1977, when the first hydrothermal vent was discovered. And scientists were astounded. They were just looking, these were chemical oceanographers. Like I said, there's lots of different types of oceanography. And these scientists were looking at chemical patterns in the ocean. They had no idea that they were going to find just mounds and mounds of animals living around this area that had this interesting chemical signature that they were seeing in their scientific studies. But they drove up onto this hydrothermal vent in their human submersible Alvin, and they saw these fields of tube worms, they saw fields of mussels, and they saw crabs and shrimp, and they had no idea what was going on because there was so much life in this one area, and that's really rare to see in the deep sea because of just relying on this rain down of sparse animal and plant matter from the surface of the ocean. You don't see these massive assemblies of animals like what they were seeing at this hydrothermal vent. And so they had to start studying it. They were wondering, okay, what is going on here? And in 1984, a similar discovery of methane seeps with these fields of microbial mats and tube worms and clam beds. And I have some videos to show you these different types of habitats that methane seeps coming up. And scientists started studying this and trying to figure out how the animals were living. And that's how they discovered the process of chemosynthesis. Just 40 years ago, we found out about this, that life can live without the sun. And this was really transformative because as we've looked for life on other planets and as we looked for life on our own planet, we always had thought that life needed to have the sun to survive. And then we realized, wait, no, it doesn't. Life can survive in this totally new way that we never thought possible. And so here's a video of methane seeps, and these are really probably my favorite habitats in the whole world. I think they're so cool and fascinating, and you can see here bubbles coming up from the seafloor, and this is from a methane seep off of Oregon, actually. And these bubbles come up, and amongst them, you can see the animals are living on the seafloor. And here we have some clams and some sea stars. And as this video moves on, we're going to see some different types of methane seep habitats. Here we have what's known, this kind of looks like ice, if you can see it in the video. And this is what's called a methane hydrate. And here is a microbial mat. As I was saying, this is a really common feature in hydrothermal vents, is these microbial mats, and animals can eat these mats, and these microbial mats use the chemicals that are coming out of the seep for food. And here we have tube worms, and these can live for hundreds and hundreds of years and grow to be meters long, or 3 feet to 6 feet long. And they are really, really cool animals, where in the top of the worm that you can see here in the video now, that they have bacteria that use the chemicals coming out of the methane seep for food. And then a lot of other animals can live on them. They make a home for other animals. And here are the clam beds I was mentioning. You can see just massive amounts of clams living in the sediment. And these too, just like the tube worms, have bacteria that live within them that use the chemicals at the seep for food. And as we've studied these habitats more, we've started to see that there's a lot of other animals that are living at these methane seep habitats, aside from just these animals that are really specific to seep habitats, these animals that we only find in methane seeps, such as these crabs. This was from an expedition in 2012. We found this population of tanner crabs, which are really similar to stone crabs, if you're familiar with that. And they were feeding at this methane seep, and it was really surprising because we never thought that they could feed on a methane seep. And one got so into it that it got thrown up off the sea floor from all of the bubbles and thrown upside down, falling back onto the sediment. And all of his friends just keep on eating, like it's no big deal to see their crab friend just get thrown up in the air. And even this crab just goes right back to eating after making it back down. And with all these discoveries, we really started wondering, okay, what is the extent of this? How many methane seeps are there? How many hydrothermal vents are there? Are other animals using these habitats for food? And so we've kept exploring, and we're still exploring every single year. And one area that is similar to the deep sea, but shallower, is Antarctica. And that's because it has 6 months of total darkness. No light makes it to this area of Antarctica for 6 months. And there's 10 to 20 feet of sea ice that cover the surface. And the water is below freezing. And so it has a lot of similarities to the cold, dark deep of the deep sea. And when we started studying this area, we found that similar to the deep sea, there's a lot of animals that live in this habitat as well. It was really surprising to us, again, because we thought 6 months of darkness, so little food, could there be that much life? But then when we started diving around, scuba diving through the ice, we've just found massive amounts of life. And as we continued exploring in this area, even here we found one of these methane seeps that I've been talking about. And here's a video of that methane seep, and you can see all that white is the microbial mats, and they're set underneath these like 15 feet of sea ice that comes down in all of these amazing formations, such as this here, and other really awesome animals that live around the sea ice, such as a seal. And it was really, really, truly alien-like exploring for this methane seep in this area because of all these features. And it just really got me thinking a lot about, wow, like, you know, what else is out there? What else don't we know? And I mean, just in the last year, we've found thousands of new methane seeps. And the potential is really limitless right now, it seems. It seems like every time that we go out, we just find more, we discover more. And when we are trying to understand these, you know, there's a lot of different ways that we can study them. So all of you listening, as you're thinking about what do I want to do? You know, if you find the ocean cool, and if you find these different types of habitats cool, you don't have to just be a biologist either. You can be looking at the chemistry in the ocean. You can look at the physics in the ocean, the geology, the microbiology, and you can study them by scuba diving, by going on ships and putting instruments out into the ocean, by using remotely operated vehicles or submersibles. And there really is so much that's left to study out there. In 1843, this is when we thought that no life existed below 1,800 feet or 540 meters. And then in 1857, we found a seafloor canyon, and we started thinking, wow, there might be a little bit more out there than we think. Then we found that life could exist below 1,800 feet, as we've seen here today. And the Challenger expedition that I talked about in the beginning found hundreds of new discoveries and made the basis for modern oceanography. And from that, we got the first map of the seafloor. And these maps are still developing. We're still going out every year and mapping the seafloor, finding new underwater mountains that are the size of Mount St. Helens in Washington, and finding new canyons that are the size of the Grand Canyon or deeper. In 1934, that was the first exploration of the deep sea, less than 100 years ago, the first exploration. In 1945, the first deep sea camera, we could actually look and see what's going on in there. In 1954, this is when we really started using submersibles to try and explore the deep sea further and see what's happening. 1977, the first discovery of the hydrothermal vent, and we found out that animals could use chemicals for food instead of just having to rely on the sun. And now in 2018, who knows what else we're going to discover as time continues to go on. Of everything that we've discovered in the ocean, we only know about 1% of what exists out there. We only know and understand 1%. That's 99% of the ocean that's left to discover. And maybe one of you will be the next to make one of these big discoveries that I've been talking about. And I'm going to come back to join you guys. And so I hope that I've really shown you today just how much exists out there in the ocean and how much potential for discovery there is. Every time that I go back out into the field, and I go actually on Thursday of this week, I'm leaving again to go research some coral reefs in French Polynesia, which is by Australia. And every time that I prepare for one of these trips, I just never even try to make any expectations of what we're going to see, because every time we go out, it's so surprising to me, and we discover something I never thought we would. And I'm always just so excited and astounded by the ways that life can live in the ocean, and by the ways that you can find connections to so many things, such as a methane seep in Antarctica under ice, similar to a moon of Jupiter that has methane and ice-covered oceans. And I think it's a really exciting world out there, and I'm so excited for all of you going into this world, because there's going to be so much more for all of you to do as technology keeps making it possible for us to go deeper down in the ocean and to explore for more. So thank you for your time, and I've had a really good time talking with you, and I'm looking forward to your questions.
Awesome. Great talk, Sarah. I think that one pie graph was so powerful about the 99% that there still is to discover about the ocean, because I think I heard a statistic that we know more about space than we do our own world's ocean. And so there's always something new to discover. There's always new things to try to bring knowledge for humanity. So awesome points there. So we'll go around for questions now. So I will unmute. We'll start with Miss Zimmer's classroom. If you guys want to come up and ask a question, Sarah will be happy to answer them.
Thank you. Okay.
Hi.
Hi. How can we convince the people not to throw garbage out, which ends up in the oceans? And how can we clean the ocean so it does not have a negative impact to habitats?
That's a really good question, and it's really true that in a lot of my explorations in the ocean, I've seen garbage in the ocean. And in one of the videos I showed, actually, you could see a red cup on the bottom of the sea floor. And I think it's important for people to see these things and to realize that what they do with their trash does eventually impact the ocean, because most things end up going into the ocean. And so I think education is a really big thing. Tell your friends, oh, don't put that on the ground, put that in a trash can, put that in a recycling bin. Go to beach cleanups. Whenever I can, I try and help out at beach cleanups, because that's the first way to have the most direct impact is to go out and clean up the trash that could be swept into the ocean soon. And there's work that we're doing right now in some of our explorations where whenever we see trash, we map it. So we put a little marker on the map so we can go back and see all these instances of trash all over the ocean. And there's people, engineers, working to develop technology to help clean up the ocean. There's a young engineer who's developed something that could work as a vacuum to suck up all the little tiny plastic particles that are in the ocean. And people are still working to design them. And so maybe that's something one of you might work on too, is developing the next technology to help clean up the oceans.
Awesome question, really relevant. So we have a question from Claire. A student asks, how many years of being in the field at college, grad, or post-grad level before you went on your first expedition?
So I went on my first expedition when I was an undergraduate, actually, when I was 20 years old. I'm 25 now, so I still am pretty young, I would say. And when I was 20, I applied for a scholarship in my undergraduate university to study abroad. I went to Indonesia and I learned to scuba dive and I studied coral reefs. And since then, I've just been so into the field, and I try and find every opportunity I can to get back out there. And I think if you set your mind to something, if that's something that you're interested in, is going into the field and going on these expeditions, just set your mind to it, and you can find ways to get out there. I think I spend 3 months a year right now out, and I still do a lot of work here and a lot of science, but there's a lot of potential if you're interested in it, to get out there.
Okay, awesome. So we'll go to Mr. Adams' classroom. If you guys want to come up and ask your question, your mic is unmuted.
Hi.
Hi. What were your inspirations to become an oceanographer?
That's a really good question. So like I said, I grew up in Florida, and I grew up on the beach, and I was always so fascinated with the ocean. I'd go swimming and I'd see all these little critters living in the sand at the beach, and all these fish swimming around, and I thought it was so cool. And then I started reading about the deep sea explorations, and I started seeing pictures from the deep sea, and it was crazy to me the way that life looked down there, and I was so fascinated with it, and I just wanted to work to try and understand how these different animals were surviving in such weird ways, and how they worked together and lived in this big vast ocean that we knew so little about. And so I think it's really just this unknown that's always really been awesome to me, just the unknown of the ocean, how much we can still discover, and just the curiosity of the world around us.
We have some great questions today. Great conversation. So Miss Ragsdale classroom, if you guys want to come up, you have the floor.
Right in front of the camera.
There? Let me just, there we go. There you are.
Okay, whenever you went scuba diving, what was the one thing that impacted you the most?
It's a good question. I think there's been a lot of things. I've scuba dived in a lot of different areas, in tropical reefs, in the rocky reefs off of Oregon, which is where I am now, and then the Antarctic scuba diving. And I think the Antarctic scuba diving was, personally for me, a really powerful experience, because it was something that was kind of scary to me at first, because I knew I would have to go through this hole in the ice, 10 feet of ice. You just drop through it, and then you end up below it, and you have your dry suit on, and you can inflate it and swim around. And I was really scared of that, of being under 10 feet of ice. I mean, what was that going to be like? I had no idea. But I was so curious about what I would see down there and how cool everything would look. And so I did the trainings, and I got there, and it was time for me to do my first dive. And I was sitting on the edge of the dive pool, and I was really nervous. And then I was like, okay, it's now or never. And And I remember I just jumped through, and the water was so dark because there's so little light that can make it through the ice. And so at first I couldn't see anything, and then my eyes started to adjust, and I just saw so many animals everywhere. The seafloor was covered in sea stars, worms that were like massively long, and seals and corals and sponges, and there was so much going on that I wasn't afraid anymore because I was just so excited by everything around me. And I think it was just, wow, you know, looking around, I can't believe that there's this much beauty out there, there's many cool things. And I think it really inspired me to also, you know, not let fear hold me back from doing certain work in any area, that you can accomplish anything and you can do a lot more than you think you can.
That's a great message. How did you deal with the cold going into Antarctic waters?
Yeah, it was really cold. So it's 28 degrees Fahrenheit or -2 degrees Celsius. And we were kind of, it felt to me, I really kind of felt a little bit like putting on astronaut gear when we were getting ready. So we had these thick suits that we wore underneath of our dry suit, and they're kind of like a sleeping bag that has arms and legs, and you put that on, and then you have a dry suit, which is this suit that goes over it, and it seals at your wrists and your neck and your legs, and no water gets in. And then you have a bunch of hoods that you put over your head, and then your face right here is exposed to the water, but you have gloves on with thick then underneath of them. And so your face kind of just goes numb instantly. So it's kind of shocking at first, and then you just kind of spend the rest of the time being a little bit cold, but not minding it because everything looks so cool that it's okay to be cold if you're if you're seeing so many cool things. And it's a lot better now than it used to be. In 1960, when scientists would dive in Antarctica, they wore wetsuits and they were just freezing cold the entire time. And so now technology has allowed us to be a lot more comfortable when we're doing it.
Good to know. I didn't know that part of your face would be exposed as well. So we have Miss Holloway's question. Miss Holloway's class, if you guys want to ask a question, to the floor.
Sure. I think we want to know about some shipwrecks in the ocean. Is it a good idea to leave these things on the bottom of the ocean to be biomes for other creatures, or is it best to try to bring these things up because they could cause pollution and whatnot from all the artifacts?
That's a really good question, and I've had the good fortune of being able to explore some shipwrecks with the exploration vessel Nautilus using their remotely operated vehicles, and when we've explored them, we find a ton of animals living on them. As you said, they use them for habitats, and they've really become part of the seafloor there. It becomes a structure that things can live on. And there is some thought, like you're saying, of, okay, should we take some of these out or leave them? And so many of them have been there for so long that I think the cost and the act of actually removing it would disturb the habitat more than just leaving it there and letting the animals live there. And you see fish swimming around everywhere, corals live on them. And so I think the opinion right now in the community is that it's good to leave those shipwrecks there to provide homes for other animals because they're doing a good job at it right now.
We also have a question coming from YouTube. Paul wants to know if you've noticed any radiation affecting Pacific Ocean ecosystems.
I have not. That is a concern that people have been looking at from the earthquake that happened on the other side of the Pacific, but we haven't seen any impacts here. And the latest research that I've seen says that the amount of radiation within the water is a very, very small amount that is less than getting a CT scan or going on a plane ride or something like that. So it's really looking like it's not going to be that harmful to a lot of animals as of right now.
Okay, that's good news. So we have a couple more minutes for some more questions. So we'll go around to each classroom. We'll try to do once more. So we'll start again at Ms. Zimmer's classroom. If you guys want to come up, we have time for one more classroom, or one more question. Oops, sorry, Igor, let me just unmute your mic. I forgot to do that. You're all set to go.
Do you find the possibility of life on other planets shocking, or did you kind of expect it?
That's a really good question. I think I used to find it more shocking, and now that I've explored in such weird areas on our own planet and seen that life seems to always find a way, I kind of think that I kind of have become to a state where I expect it. I think that there's a lot of habitats on Earth that are very similar to habitats on other planets or other moons, and that if life can live there, then it would make sense that perhaps life could also be living in these other areas. And so that's a big interest of mine as I continue forward as a scientist. I'm really interested to take my research and apply it to understanding and looking for life in these other systems. And I'm very optimistic that if not within my life, within the life of one of you in this classroom, perhaps we'll make this discovery of life on a new planet or a new moon.
Okay, Mr. Adams' classroom, if you guys have another question, you will have the floor.
Yeah. So with the hydrothermal vents and the methane seeps, are they able to support bigger organisms?
That's a good question, and that's something that we are actively researching. And so I'm finishing up a project right now working with those crabs that I showed in the video, the crab that did the big flip from all the bubbles coming out of the seafloor. And we found that crab is actually eating things from the methane seep. And the more that we're looking at different habitats, we see these larger animals, we see fish, we see crabs, octopus, we see them around these methane seeps and hydrothermal vents, and we don't have scientific data to support if they're using these habitats for food in a lot of instances yet, but we're getting to the point where we can better understand if these larger animals can support themselves from hydrothermal vents and methane seeps, and it's looking like they can.
Exciting prospects. So Miss Holloway's class,
Yeah.
you guys another question.
Have you ever encountered a cuttlefish in the ocean?
I have. I saw one when I was scuba diving in American Samoa, and I thought it looked kind of like a spaceship when I saw it. Actually, they just kind of float along the water in this really weird way. They're really cool animals.
They are funny. So Claire, do you guys have another question at all? If you want to type one out. If not, we'll go to Miss Ragsdale. Okay, silence means no, maybe. So Miss Ragsdale, class, if you guys have another question, you have the floor.
Wait, hold on. Let me look at it. If there was one thing that you could do for the ocean, what would it be and why?
That is a good and hard question. There's a lot of things I would like to do for the ocean. I think the thing that's most important to me is sharing the ocean with people. I want everyone to be able to know about these crazy cool habitats and these crazy cool animals that live in the ocean. And I hope that by them knowing about these crazy cool habitats and crazy cool animals, that it might make some people care about protecting the ocean and doing better at watching where they put their trash, or doing better at just protecting the ocean in general and looking out for it. And so I think that if I could do one thing, it would just be to share the ocean with other people in hopes of helping to protect it.
I think that's kind of what science communication is about, is just spreading awareness so people know what their actions are affecting, because a lot of the times these problems are caused just a result of not being aware of what the consequences of your actions are. So that's awesome. And Paul from YouTube has another question. He wants to know if you've discovered any new species and what kind of work it takes to document a new find, if you know.
Yeah, so I think every time we go out, we find something that we aren't sure if it's a new species. And it takes an expert to be able to identify that. There's experts in all these different fields of animals. my advisor here at Oregon State University discovered a new species of crab called a Yeti crab that dances around hydrothermal vents or methane seeps. And it has these bacteria that lives on its claws that it can eat. And there's some videos of it online that are really funny. And there's been new worm species that have been discovered recently. There's been other crabs. There's been little snails that were discovered recently. And some of the videos I was showing, there are all these little white specks in the seafloor. And some people think that might be a new species of snail. But it takes a lot of work to actually confirm that you have a new species. So a lot of people have to look at the organism, look at the way that it looks under a microscope, look at the way that its body is shaped, do genetic studies, so look at its DNA, see if it matches up with anything. And then it has to be approved through several steps before it becomes officially a new species. But there are definitely a lot of new species still to be discovered in the ocean. And it happens quite a lot, I would say.
Super cool. So I think that wraps up all the time we have. So thanks again for joining us, Sarah, and thanks everybody for your great questions. There was a great talk going on today. So thank you, Sarah, for joining us and for all that you do and being an inspiration for the next generation of adventurers and scientists. So for our classrooms and anyone else watching, you can go to explorebytheseatofyourpants.com to check out future events we have coming up. So thanks to everybody for participating, and we will be signing off and hope to see you guys next time.
Thank you so
Bye,
much.
Guys.
Bye.
See you, everybody. Bye. Thanks for joining us, Colorado. Bye, guys.